Your laptop is not dying. It is just dirty, throttled, and running software that treats it like a server farm. The machine you bought 3 or 4 years ago is probably still fast enough for everything you actually do. The problem is what has happened to it since then. Thermal paste that has turned to powder. RAM being shared with things you never opened. A spinning hard drive from 2019 hiding inside an otherwise decent chassis. An operating system full of telemetry, startup bloat, and background processes you never asked for. By the end of this, you will know exactly which of these problems your laptop has, which upgrades will fix them, how much each one costs, and whether switching to Linux will actually help or just add a different set of problems. Stick around. The laptops we are talking about are the ones sold between 2020 and 2022. That generation covers machines with Intel 10th, 11th, and 12th generation processors, AMD Ryzen 4000 through 6000 series chips, and Apple Silicon starting with the M1. Some of these are still genuinely competitive hardware in 2026. Others were mid-range or budget machines that were never going to age gracefully. What they all have in common is this: they are old enough to feel slow, but young enough that replacing them is hard to justify. A new mid-range laptop in 2026 costs somewhere between $700 and $1,200. The upgrades we are talking about today will cost you $30 to $200 total, depending on what your machine needs. The math on keeping the old one running usually wins. The important thing before spending anything is knowing what is actually wrong. A laptop that takes 3 minutes to boot probably needs a solid-state drive, a clean OS install, or both. A laptop that runs hot and throttles under load needs thermal paste and better airflow. A laptop that feels sluggish with 12 browser tabs open probably just needs more RAM. These are different problems with different fixes, and we are going to work through all of them. Before touching a single screw, run a proper diagnostic. On Windows, open Task Manager and watch the CPU, RAM, disk, and GPU columns while you do your normal work. Disk usage is consistently hitting 90 to 100%. Your drive is either dying, almost full, or an old hard disk drive that was never going to keep up with a modern operating system. If RAM is sitting at 85% or more with nothing particularly demanding open, you are memory constrained. If the CPU is maxing out and the laptop is hot to the touch, you are thermal throttling. On macOS, the same information lives in Activity Monitor. Run it for 10 minutes during a normal session and look at the memory pressure graph. Green means fine, yellow means tight, red means you are swapping to disk, and that explains everything. On Linux, HTOP and sensors are your tools. Install them both if they are not already there. This step costs nothing and takes about 10 minutes. Do it first because everything else depends on what you find. Now the two upgrades that move the needle most for most people. RAM first. If your machine shipped with 8 GB, it was barely enough in 2022 and it is genuinely not enough in 2026. Chrome alone can consume 3 to 4 GB with a handful of tabs open. When your operating system runs out of physical RAM, it starts using the drive as overflow. Even with a fast solid-state drive, that swap process is dramatically slower than actual RAM. The fix is upgrading to 16 GB minimum and 32 GB if your budget allows. Check iFixit or your manufacturer's specifications first, because many thin and light laptops from this era have RAM soldered directly to the board and cannot be upgraded at all. If your machine is one of those, we will get to what you can still do in a moment. If it has accessible RAM slots, a 16 GB DDR4 kit runs around $30 to $50 right now. Solid-state drives are the second upgrade. If your laptop shipped with an SSD already, check its health using Crystal Disk Info on Windows or Disk Diag on macOS. An SSD with health below 80% is starting to degrade and should be replaced. If your laptop shipped with a traditional spinning hard disk drive, replacing it with a solid-state drive will feel like a completely different machine. Boot times drop from 2 to 3 minutes to under 20 seconds. Application launches go from painful to instant. A 1TB M2 NVMe drive runs around $60 to $80. A 5-inch SATA solid-state drive for older chassis is closer to $40 to $60 for a terabyte. Here is the upgrade most people skip, and it has an enormous impact. Thermal paste is the compound between your CPU and its cooling block. It transfers heat from the chip into the metal heatsink that the fan then cools. After 3 to 4 years, most factory-applied thermal paste has dried out, cracked, or separated. When that happens, heat transfer efficiency drops significantly. The CPU gets hotter than it should, hits its temperature limit, usually around 90 to 100 degrees Celsius, and automatically reduces its clock speed to protect itself. That is thermal throttling, and it is why a laptop that tested well in 2021 feels sluggish today. Repasting costs around $10 for a quality tube of thermal paste. Thermal Grizzly Kryonaut and Arctic MX6 are both solid choices. The process means opening the laptop, removing the cooling assembly, cleaning the old paste off both surfaces with isopropyl alcohol, and applying a fresh pea-sized amount before putting it all back together. Plan for 30 to 60 minutes depending on your model. the performance difference is measurable. A badly throttled laptop can recover 20 to 30% of its sustained CPU performance from a fresh-paced application. On machines like the Dell XPS 15 or the Lenovo Legion series, which ran hot from the factory, the difference is even larger. You are not doing anything exotic. You are just restoring the machine to how it was supposed to perform from day one. The battery situation is more nuanced than the hardware upgrades. Lithium-ion batteries degrade by roughly 20% of their original capacity over 500 charge cycles. A laptop bought in 2020 that has been used daily has probably gone through 500 to 700 cycles by now. At 700 cycles, you might have 60 to 70% of the original capacity left. If the machine originally lasted 8 hours, you are now getting 5 to 6. That may or may not be a problem depending on how you use it. On Windows, open a command prompt and type power_battery report. This generates a full report showing your design capacity versus what the battery can actually hold today. On macOS, hold Option and click the battery icon in the menu bar. Any health reading below 80% is degraded by Apple's own definition. If replacement makes sense, batteries run $30 to $80 depending on the model. iFixit sells matched replacement kits with tools included for most major laptop lines. HP and Lenovo make battery replacement relatively accessible. Certain Dell XPS models require near-complete disassembly to reach the battery. Check the iFixit repairability score for your specific model before committing. A score of 7 or above means the job is manageable with basic tools and patience. Below 5, a professional service might save you more trouble than the money costs. Now the operating system, because bloat is real and it compounds over time. On Windows 11, start with the Startup Program list. Open Task Manager and go to the Startup tab. Disable everything that is not a security tool or something you actively need at boot. Teams, Discord, Spotify, OneDrive Sync, manufacturer update utilities, none of them need to launch before you have opened a single window. Cutting the startup list from 15 items down to 4 or 5 can shave 30 to 60 seconds off boot time on its own. Storage is the second intervention. Run the built-in disk cleanup tool and include system files. Enable Storage Sense if you have not already. On a machine with a 256GB solid-state drive, which was very common in this laptop generation, getting the drive above 85% full causes measurable performance degradation. Windows starts struggling to find space for temporary files and virtual memory. If you are close to that threshold, either upgrade the drive or move large files off it. On Mac OS, the story is cleaner. Apple Silicon machines from this era, the M1 and M2 generation, have aged better than almost any other laptop hardware from the same period. The unified memory architecture means even an 8GB M1 handles 2026 workloads better than many 16GB Intel machines from the same year. For Mac OS on Intel hardware, the same startup cleanup logic applies, and resetting the system management controller can resolve persistent thermal and fan issues that have developed over time. Now the Linux question, and the honest answer is that it depends, but in specific, definable ways, not vague ones. Linux is worth it if your laptop shipped with Windows Home and you primarily use a browser, a text editor, and email. A lightweight distribution like Fedora 40 or Ubuntu 24.04 LTS will run faster, use less RAM at idle, typically 900 megabytes to 2 GB versus Windows 11 2 GB or more, and give you a clean, current system with no manufacturer bloat. Linux is also worth it if your machine is borderline unsupported by Windows 11. Some laptops from 2020 to 2021 technically meet the requirements, but perform poorly due to driver limitations or TPM edge cases. A modern Linux distribution on that hardware will often outperform the same hardware running Windows. Linux is not worth it if you depend on software that has no real alternative on Linux. Adobe Creative Cloud, certain enterprise VPNs, some CAD tools, and games with kernel-level anti-cheat are all still areas of genuine friction in 2026. Proton compatibility for gaming has improved a lot, but it is not universal, and chasing compatibility takes real time. And Linux is not worth it if the person using the machine is not comfortable troubleshooting unexpected behavior in a terminal. Linux Mint is genuinely accessible for non-technical users, but things will occasionally go sideways and require looking something up. If that sounds like a deal breaker, the OS optimization steps on Windows or Mac OS will get you most of the way there anyway. A few words on opening specific machines, because not all laptops are created equal in this regard. ThinkPads from this era, particularly the T and X series, are among the most serviceable laptops in the industry. Most have rubber-plugged screws, clear disassembly paths, and downloadable service manuals directly from Lenovo. RAM, storage, and batteries are all accessible. This is the best case. Dell XPS 13 and XPS 15 models from 2020 to 2022 are more complex. The XPS 13 has RAM and storage soldered in certain configurations, so check your exact model number before assuming anything is upgradable. The XPS 15 is more accessible, with user-replaceable RAM and storage, but the battery sits under the motherboard in some revisions. HP Spectre and Envy models from this generation vary considerably by configuration. The HP Maintenance and Service Guide for your specific model is freely available from HP's support portal and worth reading before touching anything. Asus ZenBook and VivoBook models are generally accessible, with most screws visible after removing the bottom panel. Teardowns are usually faster than comparable Dell or HP machines. Apple MacBook Air M1 and the M1 Pro MacBook Pro have all memory and storage soldered to the board. There is nothing to upgrade internally on these machines. The good news is that the M1 generation was so well engineered that most of them do not need hardware intervention anyway. Software optimization is where to focus. So who is this for and who should skip it? The person who gets the most from all of this is someone running an Intel Core i5 or i7 from 2020 to 2022, or an AMD Ryzen 5 or 7 from the same period. With 8 GB of RAM and an older or degraded drive, those machines have real headroom that is being wasted by fixable problems. The person who should skip the hardware work is someone whose machine has fully soldered internals, certain Dell XPS 13 configurations, most ultra-thin designs from this era, and all Apple Silicon MacBooks. For those, the OS optimization and Linux decision are the levers that remain. The person who should consider replacing the machine is someone running a 6th or 7th generation Intel processor. That is 2016 to 2018 hardware. Outside the window where this math works, or someone whose machine cannot run Windows 11 and is not comfortable with Linux. In that case, a refurbished business laptop from 2022 to 2023, a ThinkPad T14 Gen 3 or a Dell Latitude 5430, can be found for $300 to $450 and gives you a clean, warranted starting point. One final pass with the numbers, because this is where the argument lands. RAM from 8 GB to 16 GB, $30 to $50. SSD upgrade or replacement, $40 to $80 for a terabyte. Thermal repaste, around $10 in materials. Battery replacement, $30 to $80. Full hardware refresh on an upgradable machine, $110 to $220, against a replacement cost of $700 to $1,200 for a comparable new laptop that is a strong case for repair. Particularly if the chassis is solid, the display is still good, and the keyboard still works. The honest caveat is that not every machine from this era is worth saving. Dead pixels, failed keys, or a cracked chassis changes the calculation. But for a physically intact machine that is just slow, the RAM, the drive, the paste, and a clean OS will give you another 2 to 3 years of genuinely usable performance. This is not about nostalgia. It is just the more sensible option, and most of the time it works. Everything mentioned is linked in the description. Drop your laptop model in the comments if you want a specific read on whether upgrading makes sense for your machine. I do go through them. If this was useful, subscribe to New for Tech. We cover the practical side of tech, what is worth buying, what is worth keeping, and what is worth moving on from. Good luck in there. Wear an anti-static wrist strap.